Dear learners, I welcome you all to this session. In this lecture, we are going to cover about power plant. In general, we have lot of energies are available which is used to produce an electricity. In this presentation, we are going to see about the power plants, especially hydroelectric power plant, thermal power plant, diesel power plant and nuclear power plant. These are the power plants which is used to produce some energy. Before going to see these kind of power plants, we should know about the energy conversion. Sometimes the mechanical energy may converted into electrical energy. The chemical energy may converted into mechanical energy. So we have different kind of energy conversions takes place in these power plants. Let we see one by one. Dear learners, this is the layout of hydroelectric power plant. In this power plant, we have some constructions layout shown in this figure. Here you may consider this is the dam wall. Behind the dam wall, we have a catchment area, that's a reservoir. This is the level of water, head level of water, and here we have a energy stored behind this wall. This is called static energy, that is rho GH. The static energy is stored behind the wall of this dam. Here this is the water flow passing through this pipeline. This pipeline may call it as penstock. This is made up of concrete one, and then here we have a surge tank which is used to reduce the back pressure, and this is the pressure tunnel, and this is the gateway for open and closing purpose. Here this is the inlet valve. This is used to control the flow of water. Here you have a turbine which is used to produce some mechanical energies. Here you have a draft tube which is used to send the water. After using the water in the turbine, we can send, it is attached with the tailwater level for irrigation purpose. Here you have an electric generator, control room, transformer and electric cable line, that is a power line. Initially the water is stored from the catchment area and it is stored in a dam. Now the enormous static energy is stored behind the wall. Now we are going to open the gate. The free flow naturally happen, so that the high pressurized water will passing through this pipeline or a penstock or a tunnel. It will come to reach the inlet valve. Here the valve is totally in different conditions, because here you have a symbol of the nozzle, that is, this is a symbol of nozzle. The conversion takes place. So here the water will passing through this line, then it will come out this side. So here the pressure will drop. Here the pressure is dropped this side, then velocity of the water jet will increase in the outlet of the nozzle. So due to increasing the velocity of the nozzle, we can, due to increasing the velocity of the fluid flow with the help of the nozzle, we can attain or we can run the turbine. Here the high velocity of water jet will hit the turbine blade. Due to applying some force on the turbine blade, the turbine can get rotate. Due to rotation of the turbine, we can get the mechanical energy. Here you have a static energy, then here you have a kinetic energy. So the static energy or a static position converted into dynamic position due to static energy into kinetic energy. So that kinetic energy will reach the nozzle, the pressure will drop, velocity of the water jet will increase. Due to increasing the velocity of water jet, we can attain the power while hitting the water jet on the turbine. The outlet of the turbine is rotor. That rotor rotates because of the velocity of water jet. Here this mechanical energy is connected with the electric generator. The generator, the main purpose of generator is create an electricity with the help of turbine. Here the turbine is output is mechanical energy. That mechanical energy as an input to the turbine electric generator. The electric generator can taken as an mechanical energy as an input, and then it will give an output as an electrical energy. That electrical energy can lift or can transfer with the help of electric cables with the arrangement of control room and then a transformer and then power lines and all. These are the construction of hydroelectric power plant. Here after hitting the water, after hitting the turbine blade, the water will flow to the river with the help of draft tube for irrigation purpose. These are the structures which is used to generate the power from the natural energy like water. The water is converted into electricity with the help of hydroelectric power plant. So the main advantage of this plant is hydroelectric plant is highly reliable, first one. The second one, maintenance and operational charges are very low. And third one, running cost of the plant is very low. The efficiency of the plant does not change with ages, and it takes a few minutes to run and start the plant for power generation. Variable load do not affect the efficiency of the hydroelectric power plant. These are all the advantages of this hydroelectric power plant. Then if we are considering the disadvantages, the initial cost of the power plant is very high. It takes a long time for the erection of such plant and the construction of the dam. And third one, loss of land suitable for agricultural purpose. Similarly, water in the reservoir is lost by evaporations. These are all few disadvantages of this hydroelectric power plant. Now, we can see another power plant. Dear learners, this is the layout of steam power plant, or it may be called it as thermal power plant. This thermal power station, which is located in many places, if you are considering the regional things, which is used to generate the power with the help of coal and water. Here you have splitted this power plant into mainly 4 circuits. One is coal and ash circuits. First one, coal and ash circuits. Here you may consider this is the coal and ash circuits. I am showing this way. And then the second one is air and flue gas circuits. The air and flue gas circuits means the atmospheric air will come to this way, and then it will come to the boiler, and then it will come this way, and then again it will come to this way and went to the atmosphere through the chimney. This is air and flue gas circuits, which is denoted by the short lines. And then third one is water and steam circuit. Water and steam circuits. The water is getting from the well, then it will passing through this way, and then it will come down to the turbine, and then it will back to the hot well. This is the water and steam circuits. And then last one is cooling water circuits. This is the cooling water circuits. It is covered in this area only. This is cooling water circuits, which is covered in this area. Now we will see the different kind of circuits one by one. First we will take coal and ash circuits. This is the first one. Here the coal and ash. So initially the coal is a medium to produce the energy, electrical, heat energy. So for what purpose we are burning the coal means here we are going to burn the coal, so we can attain the power like a thermal power. That thermal power which is used to heat the water. So the water can get heated with the help of the boiler. Due to conduction, water get heated. So the hot water can converted into dry steam and then superheated steam with the help of this area. So now we are going to only concentrate on coal and ash circuits. Here we have a coal storage area. The coal is stored in this area. Then with the help of coal handling equipments, we can bring the coal to the furnace area. The furnace area which is used to burn the coal, so that coal may converted or then can give the heat energy to the boiler. After that it may converted into ash. So with the help of ash handling devices, we can bring that to the store area, ash store area. This is the coal and ash circuits. Then second one, air and flue gas circuits. Air and flue gas circuits means we can get the air from the atmosphere. So the atmospheric air is collected from the atmosphere. That air is passing through the air preheater, because of once the air which is used to send the furnace, for what purpose air is collected from the atmosphere means that air which is used to increase the burning capability or capacity of the coal inside the furnace. So that air may be in a moisture condition when it is in a cold season or winter season, it may be in a rainy season. So that we should preheat the air. So we can preheat the air in this area. So how we can preheat the air means we can't separately burn the coal for this one. So we can use the flue gas circuits, the flue gases. So the flue gas contains some heats. We are utilizing that heat for improving the efficiency of the stations, so that we can utilize the temperature or a heat from the hot flue gases with the help of air preheater. So here the air is sent through the air preheater, the air is get heated or get little warm up in the air preheater region. So then it will send to the hot air sent to the furnace, and then this hot air after sending to the dust collector, because of even after burning the fuel the flue gases will takes place. So that flue gases containing lot of small particles as a dust particles in this area, so that you should collect in a dust collector, then it will send to the economizer. So here the economizer, for what purpose we were send the flue gases through the economizers means, here you are sending the water through the economizer to the boiler. Before going to enter into the boiler, the water should be get heated or warm up, because of if you want to increasing the speed of the boiling conditions, you should not send the cold water to the boiler, so that we can send through the economizer. While the water is sending through the economizer, the flue gases containing some temperature, it will absorb, the water will absorb the temperature from the economizer, so that the flue gases sent to the economizer, so we can utilize the heat as much as possible. Then the hot flue gases again sending through the air preheater, and then draft fan, and then chimney, and to the atmosphere. So here the chimney which is used to send the flue gases to atmosphere in a certain level height, so that it will not affect the surroundings. So these are the circuit of air and flue gases. And the next one, water and steam circuits. If you are considering the water and steam circuits, the water is stored in a hot well. Here you are using the feed pump, the water feed pump. The water is pumped by the water is pumped to the boiler from the well to the through the economizer to the boiler. So here already I told the economizer which is used to preheat the water, the warm water is sent to the boiler. The once enter into the boiler get heated because of the furnace. So due to conduction, the water also get heated. Initially it is in the wet steam conditions, and then it will convert it into super steam conditions. So after attaining the dry steam and the super steam, the high superheated steams are sent to the turbine. Here you are using steam turbine. So steam turbine which is used in the steam power plant. So here the very enormous pressurized superheated steam will hit the turbine blade. So the turbine can converted that heat energy into pressurized energy into mechanical energy, which is attached with the shaft. This shaft is attached with the generator. The generator will generate the electricity with the help of steam turbine. So if you are considering the steam turbine which is increasing the efficiency of this unit, it does not look like a hydraulic turbine, because of the hydraulic turbine which is only used in the hydroelectric power plant. Here we are using steam turbine. It may be an impulse or reaction turbines. The steam turbine which is attached with the generator, so the mechanical energy is transferred from the turbine output to the generator input. Here the generator which is produce the electricity will go through this way with the help of cable transformer arrangements. So here the steam, again the steam come back to the hot well through the condenser. So what happened in through the condenser? So we will see the condenser which is used to cool the turbine steam, so that the steam can get cooled and then it will converted into water, then it will come back and stored in the hot well. This is the water and steam circuit. The next one, cooling water circuits. So cooling water circuits means here you have condenser. The condensation takes place on the steam. The steam already finished its work, natural work in the turbine. Then outlet of the turbine is a mechanical energy, and the another way the steam will passing through the condenser. Here we should cool the steam so that it will convert it into water. So how it is cooled means with the help of cooling circuits. In these cooling circuits we have some parts. One is cooling tower, another one is cooling pump. So here you have a sump. So in this the cooling water is collected in this area, so that the cooling water is pumped by the water pump, cooling water pump, then it will send to this condenser. Due to condensation takes place, the heat is transferred from steam to this cooling water. So cooling water absorb the heat from the steam, then it will converted into what steam converted into water, then it will stored in the hot well. The cooling water absorb the heat, the hot water will go to the cooling tower in the top level, then it will spray in the surface to the area, so that in atmospheric air will passing in this way, the water get cooled, so the temperature will send to the atmosphere due to the natural air flow. So the water get cooled and it will stored in this sump. Again the water will pumped by the cooling water pump to the condenser. This cycle is happen again and again, so that the continuously keep on cooling takes places, so that the steam may converted into water and stored in the hot well. These are the cooling water circuits. So we covered cooling and air circuits, atmospheric air, the air and flue gas circuits, and then water and steam circuits, and then cooling water circuits. These are the layout and working of steam or thermal power plant. The main advantages of the thermal power plant is the initial cost of the construction of the plant is low when we compare with the hydroelectric power plant. The power plant may be loaded near the load center, so that the cost of the power plant, which is very important, the cost of a transmission and the losses due to the transmissions are considerably reduced. And if you are considering the disadvantages, it is also having some disadvantages. It has disadvantages. One is the transportation of fuel is a major problem for a power plant located anyway in these structures. And then the cost of the power is a major problem. The power plant the cost of the power generation is considerably high compared to the hydroelectric power plant. The smoke produced by the burning fuel when exhausted into the atmosphere causes air pollution. So the air pollution is main disadvantage in the steam power plant. And then it is utilized the coal. So coal is natural resource, but it will not renewable one. So it is not a renewable energy. So it is one of the disadvantage in this steam power plant. We can see another one power plant soon. Dear learners, this is the layout of diesel power plant. Diesel power plant, it is used to produce the power instantly. Here this is the structures. We can go from one side. Here you may consider this is the engine area. This is the engine area. So this is the muffler or a silencer. So this diesel engine, this is a diesel power plant. So the medium of the fuel is a diesel. So you know very well about the working of 4-stroke or a 2-stroke or diesel power plant and diesel engine and all. So here if it is a diesel, we should send the fuel separately and then air also separately. So it is not mixed one, because it is a diesel engine. So here the fuel stored in the tank. Here we have a filter area, fuel transfer pump, all day tank, and then here you have a filter, then fuel injection pump. Then here air filter, the air is sent to the engine. So here initially here you have a air compressor. It is used to compress the air, then fuel, then here you have air tank, starting air tank, then air is sent to this way, and this is the air filter. So initially the air is passing to the engine through the air filter and all, so that the air is compressed in the different stroke. We are very well about the strokes, we are already seen in the engine. So here the air is sent inside the engine. So here, and then at the end of the compression you are going to spray the fuel inside the engine, so that we need some injection pump. Here we have injection pump. Before that we have a filter. It is used to filter the fuel. The all day tank means in every day the tank should be in filled conditions, so that we will take the fuel from the fuel storage tank. This is the filter area. Again we are going to filter here initially, and then fuel transfer pump. So this pump, which is used to pump the fuel from the storage tank to the all day tank. Here the all day tank in a certain position, then naturally it will flow to the filter area, then again it will filter once again, and then it will send to the fuel injection pump. At the time of compression, end of the compression, the fuel is injected as a fine particle into the diesel engine. It is a normal one. So here once the engine is get fired in the power stroke or expansion stroke, the power is produced in that stroke only if it is a 4-stroke engine. So here the engine is started, the engine is running conditions, the output of the engine is mechanical energy, which is collected through the crankshaft arrangements. The crankshaft is connected with the generator. So generator get rotated with the help of the mechanical energy as an input. The output of the generator is electrical energy. That electrical energy can transfer to the pipeline, wired lines with the help of a transformer or a control room and all. So here you have a silencer, the flue gases passing through this way, so that we can reduce the noise pollution in this way if you are sending the exhaust gas through this way. And then here you have a lubricating and cooling, two purposes are available here. The hot water is come out because of the engines get heated, means the engine is heated, so that we should supply the water as a cooling system. Sometimes oil as a lubrication purpose, we are sending the oil also. If you are considering the water, the input is a water for reducing the temperature or cooling the engine, so that the hot water, the output of the engine, the hot water is come out, and then it will collected, it will send to the heat exchanger through the jacket circulating pump. The heat exchanger here, it is attached with the cooling tower and raw water pump, so that the cooling tower which is used to cool the hot water by the natural flow of atmospheric air. So this is a sump, the water is stored here. The water pumps are used to pump the water, and it will send the cooling water to the heat exchanger. So here the hot water may due to conductions takes place inside this heat exchanger. The cooling water will absorb the heat from the normal hot water, so that the hot water get cooled, and then the cooling water again will send to the engine for cooling purpose. So here the hot water again going to the cooling tower, then what will happen? The cooling tower get cooled with the help of atmospheric air, natural flow atmospheric air, and then it will send by the water pump to the heat exchanger. This cycle keep on running. So here if you are considering the lubricating conditions, the coolant oil which is used to avoid the friction between the two parts, so that we are using the oil as a lubricant as well as cooling purpose also. So that the oil is stored in a lubricating oil tank, the oil pump which is used to pump the cooling oil, the coolant oil will send to the engine output is a hot oil, then it will come back to the cooling lubricating tank. So that hot oil may get cooled with the help of some water arrangements here. So these are the things happen frequently. So the hydroelectric power plant or a thermal power plant is not similar to this one, because it is totally varying. There is no any coal or there is no any natural water to produce the electric energy. Here the chemical energy, that is diesel, which is used to the diesel engine to produce the electricity. So here the engine which is converted that chemical energy into heat energy. That heat energy can converted into mechanical energy as an outlet of the diesel engine. That mechanical energy can converted into electrical energy with the help of generator. These are the power changes happen inside the diesel power plant. The main advantage of the diesel power plant is high operating cost is the main advantage of power plant. If you are considering the steam power plant is a high operating cost, but if you are considering comparatively it is less while you are comparing with the diesel or thermal or hydroelectric power plant, but it can be respond to varying the load without any difficulty, and it occupies less space only. It can be started and picks up the load very quickly, and it requires less quantity of water for cooling purpose. These are all the main advantage of a diesel power plant. If you are considering the disadvantages, the diesel power plant alone operating cost is very high maintenance and lubrication cost. In the diesel plant, noise is a serious problem. Even though we are using the silencer, it will reduce the noise, but the capacity of the diesel power plant depends on the capacity of diesel power plant. The noise will frequently increasing, so that the noise is a major problem in the diesel power plant. The diesel power plant are not economical, where fuel has to be imported. So frequently the fuel energy or fuel cost, diesel cost is keep on increasing in a day-to-day life, so that while you are running the diesel power plant, the cost of the diesel power plant, running cost of the diesel power plant, it only depends on the fuel which is imported from the countries, other countries. So these are the main disadvantage of the diesel power plants. Then we can see the last one, that is a nuclear power plant. You will see. Dear learners, this is the pressurized water reactor plant or nuclear plant, it has two circuits. One is primary circuit, another one is secondary circuits. So in this primary circuits, which is covered by the reactor core, this is the reactor core, then this is the core or fuel rods, then this is a concrete shieldings or concrete valve to protect us from the rays. Then here you have a pressurized equalizer, pressure equalizer, then hot coolant, then it will send to the steam generator, and again it will come back to the core with the help of coolant pump. This is a thermal shielding here, concrete shielding and all. Then if you are considering the secondary circuits, it's covered again steam generator is a common for both sides. Then here you have a steam, then steam will send to the steam turbine, then you have a generator, then it will attach with the control room, transformer, wire lines and all. And then here you have a exhaust steam, here you have a cooling water areas, here you have a condensations, it's a feed pump. Dear learners, if we are starting the steam with nuclear power plant or pressurized water reactor power plant, so we can send the water to this pipeline. So initially we are starting the reactions takes place in the uranium. Here fuel is an uranium. Sometimes the fission or fusion takes place inside that. So here the temperature, enormous temperature, the heat energy is spreaded inside the area, the core fuel rod, so that the water, the coolant water sent through this way, the water will come this way, so that the water get heated or it will absorb the heat from that energy. So water may be converted into steam. Water may be converted into steam or high pressurized water, hot coolant will come out. So here the pressure equalizer, due to increasing the pressure we want to equalize that, so we have some use, it's like a surge tank in the hydroelectric power plant. The hot coolant will send through the steam generator. So here the normal water, is sent through this steam generator. So due to conduction takes place, we know conduction, convection, radiation and all. Here due to conduction, the water will absorb the heat from the hot coolant, so that the water get heated, the coolant get cooled. So here the steam generator, so the steam will be generate. Here the steam generator means normally we know about that is called boiler. So here the boiler will generate the energy like steam energy. Initially the water may converted into wet steam, then the wet steam can converted into dry steam. If you are continuously keep on supplying the heat to that dry steam will converted into superheated steam. So that superheated steam sent to the turbine get rotate with the help of the high pressurized or velocity steam, and then the mechanical energy can produced in the outside of the steam turbine, and then the steam will flow through this pipeline. Here you have a cooling water circuits, we know very well about this condenser. So here the steam is converted into the liquid state, I mean due to condensation takes place, the water steam get converted into water, again it will stored in the storage area. From that storage area we can send the water again to the boiler or a steam generator with the help of feed pump. Here you have a cooling circuits, here where we have feed pump and then cooling tower and all. The water get cooled with the help of water get heated. It means the water will absorb the heat from the steam, and then the steam will converted into water. The hot water can passing through the storage tank with the help of tower, cooling tower. So it will get cooled with the help of natural flow of air. So that this is the cooling circuit area, and then the feed water again come back to the steam generator, then this circuit will happen again and again. Here you have a cooling lines, the cooling line will circuit this area, so the water get heated from the hot coolant, so that the hot coolant get reduced in the temperature, then it will come back to the coolant reduce the temperature, and then it lost the temperature with the help of the water, then it will come back again into this core area. This is the primary circuits, it's happening in this way. This is the secondary circuits, it's happening in this way. These are the conditions and working of pressure water reactor plant, or may call it as nuclear power plant. The main advantage of nuclear power plant is the fuel used in the nuclear power plant is uranium. It does not releases chemical or a solid pollutant into the air during use or reduce the global warming effect. Space required is less when compared with other power plant. Then fuel consumption is very less. If you are considering the negative points, that is the disadvantages, is one is a nuclear power plant costs more to build than thermal or hydroelectric power plant of the same capacity, and maintenance cost of the plant is high, not suitable for varying load conditions, and well trained persons are required to operate the power plant. So these are the main disadvantage of nuclear power plant or pressurized water reactor power plant. Dear learners, now I am going to conclude this presentation. First, we were knowing about what is meant by power plant, how the energy is converted from one form to another form. In that, we are having most of the power plant. First, if you are considering the hydroelectric power plant, the main source is the water. The static energy is converted into dynamic or kinetic energy. So that energy can converted into mechanical one with the help of a hydraulic turbine, and then that hydraulic turbine which is used to produce the mechanical energy, that mechanical energy is an input to the generator, then generator will produce electrical energy as an output. So we are attaining the electrical energy from the storage water with the help of these ideas. And then second one is thermal power plant. Thermal power plant containing 4 circuits. One is coal and ash circuit, another one is atmospheric air and flue gas circuits, then third one is water and steam circuit, last one is cooling water circuits. So in the next power plant is diesel power plant. Diesel power plant, the medium is a diesel to produce the power with the help of some arrangements. And then last one is nuclear power plant. Here the uranium as a fuel to produce the electrical, heat energy. That heat energy converted into steam energy with the help of steam generator as a boiler, and then that heat energy can converted, the high steam pressurized steam energy is converted into mechanical energy with the help of steam turbine, and then that steam steam turbine produce the mechanical energy as an input to the generator. That generator produce the electrical energy. Then that electrical energy can use for our useful work. Wherever we need, we can transfer with the help of some arrangements like wire lines, control room, transformer and all. So these are the working of various power plants. I hope you are all enjoying this video lecture. Thank you.